In this case study, I will do a comparison between multiple programming languages that will show which languages are the most popular based on GitHub repository data. Then we will look at trends related to Python modules and Python web frameworks. And the best part is that we will automate the retrieval of data from GitHub using Python. We will start by writing a simple Python program to retrieve the number of code repositories in GitHub that matches a specific search. Let's find out how many repositories in GitHub match the word Python. Here you can see the number of repositories. The next step is that I would like to retrieve this information programmatically. To do that, we can use the GitHub API. To use the API to perform the same search, we can use the /search/repositories endpoint of the GitHub API. You can also see that we are passing the query string q = Python. The API returns a JSON object, and the only thing we are interested in for this case study is the number of repositories returned by every search. We are basically looking at the value of the total count attribute. To retrieve this value programmatically, we can use the Python requests module. Let's write a small program in Python that gets the response from this API endpoint and prints the value of the total_count attribute. That's cool, so we are getting back the total count attribute from the GitHub API when we do a search for the word Python. Now it's time to find out which programming languages are the most used based on the number of results from GitHub. Basically, given a list of few programming languages, we want to see how many repositories in GitHub match the name of the programming language. This should give us a measure of the popularity of every programming language. To do that, we will create a list that contains several programming languages. We will use this list to get the number of repository results from GitHub for each language. The idea behind this is to understand which language or languages are the most popular. Let's convert our current Python code into a function. The function takes as input a keyword, in this case Python, and returns the number total_count for that search. Before moving forward, we will test this function. Our function works as expected. Now I want to create a new function called retrieve repositories results. This function takes as a parameter a list, in this case a list of programming languages, and for each one of them retrieves the number of repository results from GitHub. So the input is keywords, that is a list of programming languages, and repos_results is a dictionary that the function will populate. The keys of the dictionary are the programming languages, and the values are the number of the repositories returned by the GitHub API for each programming language. you can see that in the first line of the for loop, we are calling the search_GitHub function that we have defined before. The 3-second sleep at every iteration of the for loop is needed because GitHub will limit the amount of requests allowed in a specific period of time. In case of failures, increase the sleep time. So once again, the function retrieve_repositories_results takes as a parameter a list, keywords, in this case a list of programming languages, and for each one of them, using a for loop, retrieves the number of repository results from GitHub. As you can see, the results for all the languages are then stored in the Python dictionary repos_results. The keys of the dictionary are the programming languages, and the values are the number of repository results for each language. Now we can call the function retrieve_repositories_results, passing a list of programming languages. Let's have a look at the output we get back. The only print statement in our program is the following one. So we should get a list of print statements that tell us the programming language and the number of repositories found in GitHub for the programming language. When we run our code, we get the following error. Name time is not defined. We are getting this error because I forgot to import the time module. So let's import it now. If you want to learn more about import in Python, have a look at the link to a different video in the description below. In the output of our Python program, you can see names of programming languages and the number of repositories found in GitHub for each one of them. We will now use the matplotlib library to create a bar chart of the data we have collected so far. To generate bars with random colors, we will use the Python random module. We will add two functions. The first function generates random colors, and the second function prints a graph, taking as input the dictionary that is generated by the current code. Before continuing, make sure that the matplotlib module is installed. Before creating the function that prints the graph, we need to add a new import for the matplotlib module. Here you can see that we are generating a list of colors using the generate random colors function. This list of colors will be used to create our graph. This function also will support two types of graphs, a bar chart and a scatter plot. This is why we are adding the following if-else statement. Let's give a title to our graph. And finally, let's show the graph. To draw our graph, we will call the function we've just created. Our code is generating the dictionary that contains programming languages and number of repositories first, and then it will use this data to create the graph. And now you can update the list of programming languages passed to our program to get the stats related to any languages you are interested in. In the next part of this research, we focus on Python. We want to know what are the most popular Python modules. The list of modules used in this case study is just an example, and it can contain as many modules as you want. This time we will apply a small change to the search done via the GitHub API. We will pass a search term in the same way we have done before, and we will also specify the language we are interested in. This is the new search we will do. As you can see, the query string starts with q equal, but in this case, instead of passing the name of the programming language after q equal, we pass the name of a module, in this case pandas. Then we use the plus sign, followed by language, colon, and the name of the programming language, in this case Python. We can use this API call to get back the number of repositories using a specific Python module. Let's update our code to make it more generic, so it can handle searches with and without filtering based on the language. We will update the functions search GitHub and retrieve repositories results to handle an optional parameter called language_filter. The value of the URL variable will change if language_filter is not empty. And now let's pass the optional argument to the next function. Let's comment the previous code that was going through all the programming languages, and instead we will create a list that contains several Python modules, and we will draw a bar chart in the same way we have done with programming languages. And now let's run the program to see which Python module is the winner. The winner is tkinter. Notice also how similar is the usage of the pandas and numpy modules. This is a very limited list, but it's a starting point to show you how to retrieve this type of data. Now, let's do a similar analysis with a list of Python web frameworks to understand which ones are the most commonly used. The good news is that we don't need to change anything in our code, we just have to provide a list of frameworks. Our program will retrieve the number of repositories in GitHub for the framework name and the Python programming language, and then draw a graph that summarizes the data. This time we will generate a scatter plot instead of a bar chart. From the scatter plot, you can see how popular Django and Flask are compared to other web application frameworks. I also want to check what has been the trend for Django and Flask in the past 5 years worldwide. To do that, we can use Google Trends. You can see that Google Trends confirms that Django is more popular than Flask. At the same time, it looks that there has been an increasing interest in Flask over time. It's also interesting to see how the popularity of both frameworks seems to be going down recently. I will add a link to the full source code of this project in the description below. Like this video if you enjoyed it, and subscribe to CodeFather to get notified when I publish new Python tutorials.